This is the video lesson for F equals ma. The learning target for this lesson is, I am learning to understand and use Newton's second law equation to solve real-life problems.
The success criteria for this lesson are, I can describe Newton's second law equation in words, I can describe what information Newton's second law equation can provide, and I can use Newton's second law to solve real-world problems. So what does F equals ma tell us? So let's start with the F. So F stands for force, and force is a vector. So it has both a magnitude, or a size, as well as a direction. So to know everything about the force involved in an object, we need to know both the size of it as well as the direction of it. M is the mass of the object, so how massive is the object, and then A is the acceleration on the object. And acceleration is also a vector. So again, to know everything we need to know about acceleration, we need to know the magnitude and the direction of the acceleration. And just a quick review here, acceleration is the change in velocity divided by the change in time. So if we think about the change of velocity as being our final velocity minus our initial velocity, that tells us something about the change of position or the change of velocity. So that is our acceleration. That's how we can think about acceleration. All right, and let's look at the standard SI units for force. So force is mass times acceleration. So our mass, the standard units are kilograms. The standard units for acceleration are meters per second squared. So we have kilograms times meters per second squared, and that unit is the Newton, which we call N. So kilograms meters per second squared is the Newton, or N, and that is our standard unit for force. All right, so we have different forms of Newton's second law equation that we can look at. The first form that we've looked at already is force is equal to mass times acceleration. Now, if we move the variables around a little bit, we can look at acceleration. So when we have acceleration, we have force divided by mass. So acceleration is equal to force divided by mass. And if we look at mass on the left side of the equation, we have mass is equal to force divided by acceleration. So these three forms of the equation can tell us lots of different information about mass, acceleration, and force. All right, now we're going to work on some examples where we use the F equals ma formula to figure out the answers to some problems. So we have, what is the net force needed to lift a full grocery sack weighing 210 newtons at a constant speed? Okay, so we have a net force needed to lift a full grocery sack. Okay, so the first thing we need to figure out is our net force. So F net is equal to question mark. That's what we don't have. We've got mass is equal to question mark. We have the weight, and then we want to know what is our acceleration. So in the problem, we're given a constant speed. So constant speed equals balanced forces equals zero acceleration. So in this problem, we have no acceleration. So we have force is equal to mass times zero. So it doesn't matter what the mass is in this situation. We have zero acceleration, so our force is going to equal 0 newtons. All right, example number 2. We have a net force of 15 newtons is applied to a cart with a mass of 2.1 kilograms. We want to know what is the acceleration of the cart. All right, so we're going to use this version of the equation. A is equal to F divided by M. So we have a net force. So force net is equal to 15 newtons. We have a mass is given, a mass of 2.1 kilograms, and we are looking for acceleration. So our equation says acceleration is equal to force divided by mass. So we can write that as net force. So that is equal to our net force of 15 newtons divided by 2.1 kilograms, which gives us an answer of 7.14 meters per second squared. Let's do a quick dimensional analysis for this problem. So remember that newtons are equal to kilograms meters per second squared. So in this problem, we have kilograms meters per second squared divided by kilograms. So the kilograms divide each other out, and we're just left with meters per second squared. All right, and our final example, example number 3. What is the mass? The mass of 3 gold bars if it takes a net force of 32 newtons to accelerate them at a rate of 0.86 meters per second squared. So we're going to use this version of the F equals ma equation. So mass is equal to force divided by acceleration. So let's look at what information we have here. So we have a net force, so F net is equal to 32 newtons. We've got an acceleration of 0.86 meters per second squared, and we are looking for mass. So we plug this into our equation here. So we have force, 32 newtons, divided by our acceleration of 0.86 meters per second squared, which is going to give us a mass of 37.2 kilograms. So those 3 gold bars have a mass of 37.2 kilograms. Now again, let's do some dimensional analysis here. So again, we have newtons on top of the fraction. So those are kilograms meters per second squared. And on the bottom, we have acceleration, which is meters per second squared. So our meters per second squared divide out, and we're just left with kilograms, which is the units for mass. All right, keep asking questions. It's how you learn new things.